Okay. So in the last session, what we have done, so we saw that how to work with the tasks, right? So how we can able to create a dependency, and then how we can able to implement the scheduling. We saw that in a tasks. Now, so in today's sessions related to in time travel, before going to CDC, capture data change, or we will call it as a streams. So we discussed about time travel, right? Before to before session. So there, so what is the purpose of the time travel? So we can able to so go back, and then we can able to check the data for any specific period of time based on retention time. So what you can do there, anytime you can go, and then you can get the snapshot of that particular table 1 week before how it looks like, right? That's it. 1 week before how it looks like, we can able to see the snapshot. But here the CDC or capture data change. So what it contains is, so for example, during this 1 week or during these 2 days or 3 days, whatever it may be, what all the changes we have done, what all the changes it is implemented on your table, we can able to get that information. It means, for example, we have a employee table. Okay, let's assume that this has been created on first. Okay, now, so on second, same table on second, so we have inserted records. Inserted, let's assume that 10 records. And on third, let's assume that we have updated 5 records. 5 records. And on fourth, let's assume that again we have inserted 10 records. On fifth, let's assume we have deleted 10 records. What you are doing? So you are every time, so we are every day, suppose let's assume that, so we have inserted the data, we have updated, and then we have inserted again, deleted, maybe we will update something, right? So, and so these are the transactions what we are doing on the table, on this table. When you are doing that in your time travel, what we are going to do? So we are going to implement, right? We'll see before the fourth, how the data looks like before this operation, right? Before this operation, before this third, so before this update statement, how the data looks like, we can able to see, right? It's a kind of snapshot at that particular period of time, how the data looks like. But when it is coming to streams, so on 6th, you can see the data for all these transactions in your table, right? But this is the final data. But if you want to know which record is inserted, which record is updated, which record is deleted, or so updated, inserted, so these information, do you have anywhere? No, right? We don't have these information related to which record has been inserted, which record has been updated. These kind of information not available, right? So if you want to know these kind of information, so we have to work with a streams or change data capture. We used to call it as a. So it's like a simple example. It's like, let's say, in your bank statement, in your account bank statement, you want to see your all the entries what is happening on your account. It means, so ATM withdrawals, and then online transactions, and then UPI transactions, and then credits, debits, and every information. So you can able to see that in a bank statement, right? So every entry, so like credited, debited, and then transactions, everything you can able to see that, right? The same way here also, we need to capture the changes on your source table. What are the changes you are performing when you are inserting, when you are doing any DML operations? So it has to capture the changes. That is called as streams. So you can able to capture when inserting the data, when updated the data, when you are deleting the data. For every operation, you can able to capture in a stream object on your source table. You are going to create a stream object. It contains all the changes what you are performing on your source table. That is a main intention behind your stream, where stream object. Now let's come to this one. How we are going to create in a stream. We have so terminology called so source table, or we will call it as a base table, and target table, or we will call it as a consume table, and stream object, stream object, and offset time. These are the terminologies what we need to know. Source table is what is your source table? Nothing but so on which table you are doing the changes. That is, let's assume that EMP table. Now, stream object you are going to create on your source table. That is a stream object. Now, consume table. Why you are capturing these changes? Maybe you want to maintain the history on any one particular transaction. Suppose you want to maintain in separate table, so all the deleted records in the table. So what are the deleted records? You need to send it to other table. So for tracking purpose, then that we can call it as a target table or consume table. So when you are utilizing the stream, we will call that as a utilizing utilizing stream. Then we can call it as a consuming this particular thing. We can call it as a target table. So where you are utilizing the stream, that is nothing but a target table. So now, so let's observe this, how we can able to perform this capture data changes for insert, for update, for delete. So for every transaction, insert, update, delete, everything we can able to perform here. Now we'll create a table. Observe this. What we are doing is the main intention behind this is capturing the changes. Now we have a table called employee underscore st. Okay. So now we are using this for the stream table. Okay. Now this is a table, source table. Let's assume employee ID, salary, manager ID. We have three columns. Now let's create this. Now created a source table. Now then what we have to do? We need to come here, and so we have to create a replace stream, create a replace stream. See this one. This is a stream object name on table. See this on table. This is the table. So it is asking clearly on which table. So you are creating a stream. So this is the table. On this particular table, we are creating a stream. Now let's run this. See this one. When you run this, so this is a stream. So on this particular table, so it created a stream. Now this is a stream object. It is not a table. Now if you refresh it, you can able to see employee underscore st here. This is a table, but this one employee underscore stream like a task. This is not a so uh, table. So this is a object. So now stream object we have created. Now just observe what all the things it is available in a stream. So we created this table and then stream. Now observe this. Select, for example, select star from what is a table? This is our table. Select star from table. When you run this, what are the columns we have? ID, salary, manager ID, right? Okay. So now let's come to this one. So when you are checking the data in a stream, this is a stream. Now let's observe this. Select or from. This is a stream. Now when you run this, what are the things we have? ID, salary, and manager ID. These are the same columns. It is available in source table also. And observe this metadata action, metadata update, and then metadata row ID. Observe this one, right? So what are the things we have? Metadata action is there, metadata update is there, and then metadata row ID. So here metadata action and metadata update both are very important here. We will see that. So okay. So based on this, you can identify whether this particular table so operation is inserted or it is a deleted or it is deleted. So now we have so source, this is a source, this is a stream table, and so what we required, we need a consume table. We need a consume table. Let's insert some data here. So then we will utilize a consume table also, or we will create. Before that, if you want to see the timestamp, let's observe this. This is offset time. This is related to offset time. Now observe this employee stream on this particular, what is the offset time? It is very old date, right? When it is very old date, the stream didn't performed on this particular table. When you performed the stream, when you consumed, always this date will change. This date will be updated. It means from that particular period of time, it is going to capture the changes. That is the meaning of this. Now let's observe this. We have this is a so default date, old date they have given. So for a so offset time, okay, we will see that how offset time will change. Whenever you are consuming, this offset time will change. It means at that particular time onwards, it is going to capture the changes. Now, so let's observe this one. Into this, so we will insert the data. Now what we are doing is we are going to insert the data. What we are inserting, we are inserting some values like so ID and then so salary, manager ID. Now let's check the data. See this, we have inserted 6 records inserted. Now observe carefully in a source table what you can see. See this one, ID, salary, manager ID. We have all this information. We have these 3 information. So ID, salary, and then so this manager ID. Now observe how the stream looks like. See this one, this is a stream. Observe this how it looks like. What you observed, ID, salary, manager ID. Observe this metadata action, metadata update, right? And then row ID. Now observe is these 2 things, metadata action, what it is telling. This is insert. This is insert. And what about metadata update? What it is telling? It is update equal to false. Metadata action equal to insert and then metadata update equal to false, it is telling, right? It means these are not updated records. These records are inserted records. These records are inserted records. Okay, now what we will do, so we have to use consume table to utilize this stream. Now so in the table you can see so your data, actual data. Now so in the stream you can see whatever the changes we have done. Now requirement is so based on inserted records, all the inserted records I need to capture in one target table. Okay, so let's say, so before implementing any delete or update, then target table will come into the picture. So target table is, so you can call it as a consume table. You can call it as a consume table. Now let's observe this. What we are going to do here, create or replace table. This is a consume table, or you can consider as a target table also. We are creating a new table. Now this is a new table. Okay. Now let's observe this. Insert into employee underscore consume. This is a consume table. Insert into this table from where? Select ID salary manager ID. So from your stream, see this one, from the stream object, we are inserting the data into this particular table, consume table, nothing but you can consider as a target table. Now when you do that, it means you are consuming your data from the stream. Once it is consumed the data from the stream, observe the stream data. What happened? It is empty. What happened to the stream? It has reset. It has been reset. Again, it will start capturing the changes from here. Now, observe the source table. This is a source table. If you observe, data is there. And then observe the offset time. Previously, what is the offset time? So 1970 year. Now observe the offset time here. See this one. Now, just today's date it is implemented. It has been updated. So this is the offset time now, right? Observe the timestamp. It means from this time, it started capturing the changes on your source table if you are doing any changes on your source. These changes will be captured on a stream. So from this particular time. So once you utilize the stream, then stream will become empty. It will reset. This is one of the important question. Okay, in interviews. Once you utilize the stream, stream will reset automatically. So it will start capturing the changes from that particular offset time period. Particular offset time period. So now, so let's observe this. So here, okay. So what we have done, we saw that insert, right? Let's so do another operation, delete. Delete from the table. This is the table. This is our source table. Delete from table where we'll take any one specific column where manager ID 911. Okay. Now we are deleting. Now I have deleted, right? One record deleted. Now if you check the source table, what you can see after deleted, so what is the records available in your source table? See this one, the manager ID. So is has been 911 has been deleted. It is not available manager ID, right? Only you can see 5 records. Previously we have 6 records. Now observe the stream object, what it is telling you. You can see. Observe this metadata action. What you observed? Metadata action equal to delete, right? So it's a delete. So metadata action capturing the changes. Okay, good. So now let's observe this. If you consume, what will happen? Every time when you consume, it means nothing but when you are utilizing the stream object will become empty, right? This one will become empty. Suppose now, let's assume that whatever the records you are performing, delete operations on the table, you need to keep that records in another table for our backup purpose. Then let's consume that particular table. So is a so consume table utilizing. So then we are going to insert into consume table. So from this particular stream. Now inserted. Now observe the stream object again. See this one. Every time when you utilize the stream, stream will become empty. Again, it will update the offset time. See this one. It will update the offset time. Now previously, so now current. So offset time has been updated. If you observe, see this one, it has been, see this, previously it is 18, now it is a 23, it has been updated. Now this particular thing, the offset is updated. Again, it will capture the changes. Now, what we have done, we saw that insert and then delete. Now let's observe this for the update. What will happen? Update table set. So for example, salary, we'll take salary. Salary equal to, we will take 7, 7, where salary equal to, so wherever they have the salary of 20,000, we are updating. Very important one, just observe this, what it will do, the stream object, when you are implementing update. So one record has been updated, right? Now check the data in our source table. In a source table, if you observe, you can see after the update, so how the data looks like. See this one, right? It is telling that after the data update, but here in the source table, you don't have any information related to, so which record has been inserted, which record has been updated, and then which record so is so deleted, right? This information we don't have. The final data is available in your source table. Now if you want to consume, then so if you want to utilize this, so which record is updated, deleted, so you can see that in a stream. Now observe that stream. When you observe, how many records we have updated? Only one record we have updated, right? Only one record we have updated. When you update only one record, now observe this, how many entries we have in a stream? We have two entries. Now what is the entries action? Insert and delete. Insert and delete, we can see both the things, but for inserted record also you will have a insert, for deleted record also you will have a delete, right? But how you will identify whether this is a updated record or whether this is related to a inserted record? Now observe this, it's very simple, you can able to understand. Now I will insert one more record here. This record has been deleted. Now we inserted one record, inserted, and one record I will delete. Again the same, like 1913 we will delete, id 913. Now one record has been deleted. Now if you observe the source, one record we inserted, another record we have deleted. See this one, right? So we have inserted 911, the record is available, right? The inserted records, and then 913 we deleted, right? That information is not there. Okay, this is fine. Now if you check a stream, see this one, totally you will have, we didn't utilize the stream. Until you utilize, stream will capture the changes. Now observe this one, what you can see, metadata action, insert, delete. See this, and then metadata update. So we have insert two entries, delete two entries. But how you will identify whether this is a inserted record or whether this is a updated record or deleted record? To do that, see this one. Here when you observe metadata update option, metadata update, wherever you have metadata update equal to true, then that is a updated record. See this, for the updated record, always how the Snowflake will behave is, so generally for every, it will be in a file format. It will be in a file format. Going forward, we will discuss how it will work. For every um, partition, whatever it is creating, if you do some changes, what it will do is, first it will delete that entry, and on top of that, it is going to insert. For every update, this will do two transactions. This is because of it's a file format. You cannot update the data. It will remove the complete file first. It will remove the complete file in the backend, and then it will insert the new data. That's why if you observe one thing here, see this one here. So we can able to see metadata update equal to true, deleted. This is a old record 912. For 912 we have updated wherever we have, so 20,000 we have updated with, so these particular sevens, right? See the entry. This is the previous record, deleted. What is the action? Deleted. And so this particular record, inserted. So by seeing metadata action equal to update, when this particular metadata action equal to update, so you can able to see that we can consider as a updated record. Remaining things, metadata action equal to false. This is inserted record, and then this is deleted record directly, right? By seeing these entries, we can able to understand, so which record is inserted record, which record is updated record. This is one of the so best feature in a Snowflake stream. Change, data, capture. What you want, if you want to know what all the transactions you are performing on your source table, so you can able to see all the changes in your stream table. This is the so main intention behind streams. Main intention behind streams. Okay, this is fine. Now let's come to insert, update, delete. So we saw that one thing. Uh, Snowflake is auto commit. Snowflake is auto commit. So here, so generally, what is commit? Commit means nothing but a save, right? Commit is nothing but a saving. Okay. So rollback, we have rollback. Rollback is nothing but, so we will do undo operations, right? Undo. Means if you want to go back, we will do undo operations when you are doing something. That is rollback. And so here, begin. We have a begin. So it means you are giving begin transaction. Starting transaction is started. So when you use begin and then commit, when you use begin and so this particular thing, it will not be auto committed. It will not be auto committed. It means, okay, let me show you something. So for example, so let's consume the data. After that, we will come to this begin. So what I'm trying to tell is, so if you want any transaction, if you don't want to auto commit, you have to use begin statement, begin. After the begin, you can execute the queries here. And then after that, if you want to save, you can use commit. If you don't want to save before commit, you have to use rollback. This is the option. So this is the process. So but in Snowflake, so if you don't give the begin transaction, then it will be auto committed. Suppose let's assume that on every day when you are doing something, you don't want to do any auto commit, then what you can do is we can come to begin transaction. This is so transactions, sectional controls. So transaction controls, it means whatever you are performing. So you need to control, then we can use begin and then commit row. So this, so things. Now let's observe this. So once we can let it consume the stream, then check the stream object. You don't have anything. It's refreshed, right? It's a refreshed, which we utilized. Now in a source table, we have this, right? Now observe this. What we are going to do is we are going to start begin. We started begin. executed successfully, begin executed successfully. Now I am going to insert some records, going to insert some records, these records, where within the begin. After it means after a begin execution, I am implementing, inserting some records here. Okay. So when I am inserting some records, now observe this, what will happen? How many records inserted? Three records has been inserted, right? Now, so these three records, it has to be available in your source table, right? Now, but when you check in a stream and source table, how many? You can able to see that it. But see this one, when you observe in stream, see this in a stream, how we can see? Do you have any entries? No, right? We don't have any entries because it is not committed. So before commit, what you can do? You don't want in a source table how many it is showing? 8 records, right? Observe this. It's very important. In a source table, how many we are showing? 8 records. Previously we have 3 records. After this insert, after this specific insert, we have 3 records. It is now 8 records. Now you don't want this. You have an option called rollback. See this one. When I use rollback, now observe the data in your source table. See this 5. It means it is not saved, right? Now let's do the same thing one more time. So again, so let's execute. Begin. We didn't committed. Begin. Now insert some records. Now observe this. We are using commit. We are using commit. So with the before using the commit, if you check the stream, you don't have anything. Let's observe this stream object. This is a stream. Can you see anything? No. Now observe this. It is commit. I'm using commit now. What is going to be happen? Statement successfully. Now check the data in the stream. See this? What we observed. You can able to see the things in the stream now. Now this data has been committed. It means nothing but it's saved. Now you can see 8 records. Now if you try rollback, observe this. If you try rollback after commit, it will execute. But still, if you observe this here in your table, before that, when you use rollback, it went to the 5 records, right? Now observe this, only 8 records. It means the stream. So it is going to capture. So once it is committed, once it is committed, you cannot able to roll back. Once it is saved, you cannot have. So commit means nothing but a saved. Once it is saved, you cannot able to roll back. Okay, this is begin and then so commit transactions. So in a when you are working every day in a so for some work, so in this, so if you don't want to, for example, let's say so you don't want to by default, so it should be committed, then what you will do in the beginning of the day in the worksheet, first you will start a begin statement. After that you will implement whatever you want. Begin. After that, so if you want to save, so then only you will save, so commit, then only we will execute commit, otherwise you won't do that. But so one thing what you need to remember here, Snowflake is auto commit. So these are related to this change data capture. And one more important thing called cloning option we will discuss. Zero, we used to call it as a zero copy cloning. This is very important. It's nothing but creating duplicate table, creating backup table. We will use backup. It's very simple, guys. So let me show you something here. But this is so very important concept in Snowflake. So let's say I will take this example. In cloning, when you are coming to the cloning, right? Suppose let's assume that mm, we have EMP table. Okay. Let's assume this is 1 GB data. We have 1 GB data. Now what we need? So we need to take a duplicate table, or you need to want to create a backup table for this. Then what you are going to do? Generally emp underscore backup, we will create another table, create table. So table name as select star from some table, right? Then it will be created another duplicate table or backup table, and this is also the same data, 1 GB, right? So this particular is your original table. This is a backup table we have taken, because so if something happens for this particular thing, anyway we have a backup, right? So this is one option. And if you want to do some changes, generally what we will do when you are doing some changes, so we are going to implement. So let's say so we will not implement the changes on your original table. You will take a backup, and then you are going to do the changes on the backup table, right? Your backup table. Then you are going to implement so validation, right? So for all the changes, for all changes you are going to implement on backup table, and then you will implement validation. It means you will cross check once everything. If you feel once everything is looks good, then only you are going to implement these changes, whatever the changes you have done here in your original table. Because in your original table, if you do the changes directly, if something happens, right? If something happens, then you cannot revert it, right? It will be impacted, right? That's why we will take a kind of backup table, these things, right? When you are doing this, the best practice is in Snowflake cloning, zero copy cloning. What is the advantage of this? Advantage of this cloning is, suppose we have this is a source table. This is source table. Let's assume that this is a backup table. This is a backup table. When you are doing this, we can call it as a zero copy cloning. When you are doing this one, always whatever the backup table you have created, cloned table, we used to call it as a cloned table. Whatever the cloned table it is created, always this storage will point out to this particular one. It means it will not occupy additional storage for the cloned one. Always it will be point out to your original changes, original data. It means here, if you come here, this is 1 GB occupied. Again, this is 1 GB occupied. Instead of this additional 1 GB, always it will point out in the backup table also, always it will point out to your original storage. Then what is the advantage here? Instead of 2 GB, so we have only 1 GB. The storage is one of the advantage, right? So this is nothing but zero copy cloning. Okay, suppose once you have copied, let's assume that once you have copied, then after that, once it is done, then if you done any changes for the copied one, any changes for the copied one, then it is going to whatever the things you have copied, so whatever the things you have changed For that only it will have additional charges applicable. Remaining things always it will point out to this one. Okay. And when you are using copy cloning, both the things will work individually. It will not be in sync. So both the things will work individually once it is copied. It means in the back end what will happen is both the tables micro partitions will share, and always it will point out to the original table. Okay, see this, no additional cost until the changes are made to the original or cloned one. So right, and so this we will use for the effective backup option. And then quickly spin up dev to test environment complete. This why they have given is completely, if you want to so spin up so dev or test, you have taken a backup of the dev environment. Suppose so you have this particular, let's assume that this database is dev environment. Same thing, you want to take a backup, complete thing you can take a backup, and then you will have a backup option. That is one thing. Now one before, like it's a very simple keyword we can use when you are implementing clone. So before that, okay, just observe this example. We have a CV. Let's assume that we have a CV in the drive in your system. Okay, in some document, in some folder. Now the same CV you copied to E drive in your system. Okay, then what will happen? In both the places, same CV is available, right? In a D drive and then in a E drive. Now, if you do any changes for the D drive, is it going to reflect on your E drive CV? You have a resume, you have kept that in a C drive or D drive, right? Whatever it may be. Now the same thing you copied into another drive. Then if you do some changes here, it is not going to reflect here. If you do some changes here, it is not going to reflect here. What I am trying to tell is both the things will work individually. Both the things will work individually, right? This is the option. And at the same time, so when you do any changes, so to this, it is not going to reflect it here. Suppose you have deleted this particular in E drive, still D drive will be available, right? So there is no link. So once it is copied. So here, this one also it will occupy the storage space. This one also it will occupy the storage space. But when you are using a cloning option here in Snowflake, it will not occupy additional storage. Additional storage. Whatever the changes you have done for the cloned one, for that particular portion only it will be reflected. Suppose in the document you have created two more lines. Only whatever the lines you created, for that only the storage, this cloned one is responsible. Cloned one is responsible. Now observe this. So for example, if you come here, okay, this particular thing, see this one, we have done some changes here. So only for this is this particular cloned one is there. So this is the responsible for this cloned one, right? This particular storage. So this is about zero copy cloning. Zero copy cloning. Okay. So now, so if you implement that, for example, another thing, if you copy this, if you copy this particular database, complete database will be copied. Complete database will be copied, including everything whatever you have in a database. What are the things we will have in here? So you will have a databases, you will have a schemas, right? Within the schemas, you will have a tables, right? If you want to take a backup for this, the complete, when you use a clone, the complete whatever the database is available. So like tasks, streams, whatever you created. So everything will be also, it will be copied. Task, streams, pipes, right? everything will come. Now let's observe this. Now we are in class and then public schema. Now if you observe, let's say show streams, show streams, you can able to see the streams. Show tasks, you can able to see the tasks, right? This is available. Now let's observe, we will create a clone, clone for database, so our schema, whatever it may be. So when you are cloning, just observe this, how easily we can able to do that. But remember, when you are cloning, you cannot able to clone your temporary table. Temporary table is only for that session, right? That is not possible. Remaining thing we can able to do that. See this, create or replace database, creating a new database. I will give this one backup class, for example, class pkp backup underscore clone backup. Now observe the keyword clone. What is the database? Class. It's a very simple keyword. See this one, it will copy complete thing, the database. Now observe this, when you copied the database, whatever is available in the database, schema, tables, everything will be copied. Now observe this one. It will take time because it's complete database, right? You will have some schemas, you will have the tables. Now done. See this one, class backup successfully done. Now observe this, what you can see, class backup, another database is available. Now if you go inside the database, what you can see this one, schemas. In schema, all the tables. Now it's connected to here, class backup database and then public schema, right? Now if you check, now you are in class backup database, public schema. Now if you observe this one, show tasks, see this, it's available. Show streams, whatever you have done, you have created in that, everything is available. It's a complete backup. And remember, you cannot able to do it for temporary table. When you are copying the database, temporary will not copy, will not copy, because temporary is only for the session, right? Okay, same way, when you copy the table, so table will be copied, zero copy cloning. You can use the same command. So copy, what is the command we have used? Create table, table name, and then so use the table, clone. So from which table? You can mention the table name. Same way, if you want a schema, so create schema, schema name, right? Clone, we will use the keyword clone. So from where? From which one you have to clone? So when you are mentioning these things, so what is the advantage here? It will not occupy additional storage for the cloned objects. You can clone all the things is here. You can clone the database, you can clone the schema, you can clone the table, right? So all these things. So mainly the intention behind that is so avoiding unnecessary storage, right? To reduce the storage, that is the main intention behind the same thing. So we have here, so whatever the, so we can clone everything and then we can clone, so complete thing. And we have one option called, that is related to the clone, all these things. Now we have one option called swap. Swap means, this is very interesting feature here. Now just observe this swap table. Now where we are in a class backup database. So we have both the tables. One is EMP table, one is uh, let's say employee table. Another one is EMP table, right? In EMP table, how many records we have? 4, right? Now observe this, 2 columns, only 2 columns in EMP. Let me take EMP. Another one, employee. What will happen here is swap means this particular employee table will exchange with this particular EMP table. This particular EMP table will be exchanged with employee table along with data type, along with the structure. That is nothing but a swap. Now observe this. In EMP, how many records we have? 4 records we have, right? And in employee, we have 6 records. In employee, we have 6 records. And so here in EMP, we have 2 columns. Same, right? EMP, click on this. See this one, we have 2 columns, ID and name. In employee, how many columns we have? 3 columns here. In employee, 3 columns. Now observe, when you are implementing a swap option, what will happen? Instead of renaming, we can do this one. See this one, employee swap with this particular employee table. Now when you do this, observe this one, run, it's done, refresh it here. Now observe the EMP, how many records we have? 6 records. In employee, 4 records. Observe the structure, employee is 2 and EMP is 3. What happened here? This particular structure and then columns, it assigned to this employee table. This particular records and then columns, it assigned to this EMP table. That is nothing but a swap. If you want to rename it, or so by mistake, if you want to exchange the, so because we didn't created the table name properly, so we want to exchange with some other name. So then, so we can able to implement this particular swap option. What it will do, it will exchange both the tables, so along with data as well as the structure. That is the main intention behind the swap option. Okay, so we'll stop it here. So in the next session, what we will do is we will discuss about so data masking roles creation. It will take some time and it's very important topic also. We will see how to create a role, how to assign a user, how to create a user, and then how to give the grant permission to that user. All those things we will see that in a data masking policies. Okay, any questions here?
Sir, I have a
Yeah,
couple.
tell me.
One is like when we created that stream, one of the field is like row metadata $row ID, right?
Correct.
Is there any advantage of do you use that ID anywhere?
Correct. Metadata row ID. So you can able to see for the each update record, you will have 2 entries, right? Like insert and update. So for the one particular transaction, your metadata row ID will be the same. Just to identify, for identification purpose, we can use that.
Okay. The other one, the cloning. So generally we do restoring, production reflection, dev and test environments, right?
Correct.
Also this cloning is useful. That means it won't take occupy any space if you store production data test environment.
Exactly. That is the main intention behind cloning.
Oh.
When you do that, production, whatever the data is available, we want to test it in a testing environment. When you copy or when you create a table, what will happen? Always it will occupy, right? So instead of that, when you clone, so it will not occupy the storage, and then we can use this for the testing purpose.
Oh, very nice. Thank you.
Any other questions? Anyone?
So when we are doing a cloning, you said that it is a pointer referencing the actual data, right?
Exactly.
So whatever the changes we make, so it is just a copy, right? It is not.
It's just a copy. It's not
Yeah.
like live data.
Yeah. So whatever changes we make under this cloned table, that will
Mm,
not be reflected in the original table.
correct, exactly.
Sir,
Yes,
I have question about child and parent task.
yes, yes. Tell me.
So if if A is a parent, he has
Mm,
5 child tasks.
mhm.
Does the task A has to wait until
Mm,
all child tasks are complete or
no,
will run?
no. It will run. So always a child's will is dependent on the parent.
Mhm.
Parent will keep on continuing.
Yeah, but if start
Mm,
means child has to complete his task, right?
child has to.
Complete his task and then only parent will start.
No. Once the parent is completed, then child will task. And this one so related to like scheduling. For example, before doing this like dependency kind of thing, let me tell you something. For example, you said A
Mhm.
is a parent task. Let's
Uh,
take, for example, B is a one child task, and
mhm.
C is also one, so
Mhm.
child task, right? This is our requirement. So we are
Mhm.
telling that once A is completed, the
Mhm.
B as well as C, so both has to run, right? Both has to run, right?
My it's like, if you want to
Hmm.
start, that means child has to first, right? Like us.
Aha, correct. So when you are having dependency, these
Uh-huh.
two child task has to run when you are,
Uh-huh.
especially when you are having dependency.
Uh,
So then only the parent task will run. So that
uh,
is nothing but a resuming. Yes.
Resume. Yeah.
Mm,
So 5 child has to complete their task and then A
mm.
will start.
Not complete. We cannot
Uh,
say that it's complete. We can start it.
Start. I'm sorry.
Yeah. Yeah.
The wording
Okay.
is wrong.
Yeah, that's fine. That's fine. No problem.
Thank you, sir.
Good.
Sir,
Yes, Lakshmi.
swapping is in between the database or outside the database also we can swap the tables.
Outside the database also we can able to do that. Database to database also we can swap. Schema to schema also we can do that. Yeah. Okay. Any other questions? Okay, yes, if we don't have anything, we will wind up. So thank you.
So,
So please practice. Yes.
if it is between two
What
different
questions?
databases, then what will be the syntax?
Same thing. So there is so this one, see this one. So what we are doing here, alter table, right? So
Yeah.
here we are going to use alter database
Okay.
name, swap with another database name. If it is a schema, alter schema, swap with so one schema to another schema.
Okay. Okay.
Sir, I'm not asking about that thing.
Mm,
I'm asking about the table in one database can swap with the table with another database.
we can do that. So what we will do is we are going to mention the complete address of that particular database, from which database to which database.
Okay.
So it means,
So we are
mm,
connecting parallelly two databases.
yeah, that is possible.
Okay.
So what we have to give is a set as context.
Set as
What we have to give our database
correct,
name when
correct.
we.
Exactly. See this one. When you observe this, so here, so if you want to take this, so what you will do? So just if you want to do this, class backup, this is a database name dot,
Mhm.
for example, public schema dot which table. For example, EMP table. This is a complete address, right? We have to give like this.
Okay. Okay, thank you, sir.
Thank you. Cool. Okay, guys. Thank you all. Bye.